All right, guys, we're going to talk about rate in, rate out questions. So first of all, let's talk about what they are. A rate in, rate out question is a question in which you're given a rate at which something is being either added or subtracted. Sometimes it'll be both, and those are the ones I'm going to mainly focus on, but it could be just one, like they might just have a problem where something's being added or something's being subtracted at a particular rate. And so they'll give it to you. Now, the regular type of question, if you will, for these is ones where it's like they give you an equation. They're usually calculator based, but it's possible that they could give it to you as a graph as well, in which case it's kind of like a derivative graph given question also a little bit at that point. So these questions, let's go ahead and take a look at the common questions here. We're going to say that I of t represents the rate in and O of t represents the rate out. So here's the more common types of questions that could be asked here and how you do them. So I'll go ahead and summarize it briefly. If I represents the rate at which something is being added, then the integral represents the total amount that was added. Or if O represents the rate at which something is leaving, then the integral of O represents the total amount that is left. If you want to find a total amount formula, then it's our regular final amount equals starting amount equals the net change, which is rate in minus rate out integrated. The total rate of change, this is really not too common of a question, but that's just where you subtract the rate in from the rate out. And that will tell you the total rate of change. We might see something like that. Let's see. This one represents the rate at which the total amount is being changed. So instead of this is a total rate of change, this is a total amount change. Okay. So in other words, this one tells you how fast the total is changing. This one tells you how much the amount changed by. So those are different things, amounts versus rates. Another really common type of question is if they ask you, when is the total amount increasing or decreasing, or what is the minimum or maximum? And we'll also look at finding a time when the total amount is a certain value as well. Also finding what do you get when you take the derivative of the rate in and rate outs. Something to pay attention to as you're doing these problems, some extra notes here, is things pertaining to units. So let's say f of x is a rate and it has units y per x. Rates are always something per something, so let's say f of x is y per x. Then the derivative of f will be y per x per x. Okay? Every time you take a derivative, you get another per x. So if this is already a per x, if you take a derivative, you get another per x, so it's y per x per x. Every time you take an integral, you lose a per x. So the integral of y per x becomes just y. Okay, so that's basically the idea there. Some variations that could happen with these types of questions is they may give you both a rate in and a rate out question. They may only give you a rate in or a rate out. Sometimes they're presented as piecewise functions, not just regular functions. For those ones, you got to be careful to the intervals they're giving you and making sure that you're using the correct pieces at the correct times. Sometimes they could represent the rate in and rate outs with graphs. So those are some of the variations, but your basic formulas and processes are here. So I'm going to go ahead and do a group of sample problems for you where I go through various of these common questions, and then in class we'll go ahead and practice some of the some things out of our blue books. So without any further ado, let's jump in and begin here. So here is our sample problem. Let's read it. While being stranded in a small boat in the middle of the ocean, you wake up from an exhausted nap only to find that your boat now has sprung a leak. At t equals 0, there are approximately 15 gallons of water in your boat. You can see that water starts bubbling into the boat. Your friend starts to patch up the hole. As a result, the rate at which the water is pouring into the boat is given by this function here. While your friend is patching up the hole, you start shoveling water out at a rate given by this here. The functions above are valid for the interval from 0 to 5, where t is measured in minutes. All right, so let's go ahead and take a look at number 1. Number 1 says, find the total amount of water that was added. Let's go to our reference sheet here. If you want to find the total amount that was added, you're going to take the rate-in function and you're going to integrate it on the interval that they are telling you to integrate for. So, for this particular problem on number 1, my rate-in function is f, so I will be integrating the f function. And since I want to go up to t equals 5, we can assume the starting is 0 and the ending is 5. And from here on out, it's pretty much a calculator-based question. So you would type this function here in for y1 and then calculate this, and the answer would come out to be 8.602, and that will be gallons. And so that's the total amount of water that was added into the boat over the 5-minute time period. Okay, let's go ahead and take a look at question 2. Let's find the total amount of water that was removed from the boat. So if you ever want to find out how much of something was removed or lost, then you're going to integrate the rate out function. So we're going to be working on the same time interval. So for this one, for number 2, the rate out function is the g function. That's how much is leaving. We're going from 0 to 5. And we'll go ahead and punch that into our calculator to find out how much total water was taken out of the boat. And I get about 5.590 gallons was removed. Okay. All right, let's go ahead and take a look at number 3. Number 3 says, write a function, and we'll call it w of t, that represents the total amount of water in the boat at any given time. After that, we want to use that function to find how much water is in the boat at t equals 5 minutes. So, back to our reference sheet here. If you ever want to find the total amount, your formula is going to look like this, where you have the ending amount or the final amount is equal to the starting amount plus the integral of your rate in minus your rate out. Okay, so let's go ahead and apply that here. So the amount of water, they want us to use the letter W for that, is equal to the starting amount of water. So at t equals 0, there are 15 gallons. So I'm going to put a 15 here and 0 here because that's the time that goes with that starting amount. And then I'll put a t here, and we do the rate in minus the rate out. And this is a function that will tell me how much water is in the boat at any given time. So that's part of the question. Now they want me to figure out how much water is in the boat at t equals 5. And so for that, basically, we're going to be plugging 5 into this function, which would look like this. I'm just going to be putting a 5 here and here, basically. And so once again, at this point, I'm going to punch this into my calculator, and we'll see how much boat is in the water at t equals 5. And I'm getting 18.012 gallons at that point. So it seems like we're losing the battle here against the water coming into our boat. We started with 15 gallons, and 5 minutes later, we now have 3 more than what we started with. So the water must overall be coming in at a faster rate than it was leaving. But let's continue. Number 4, find and interpret W prime of 5. So number 4, W prime of 5. Well, for that, I'm not going to look at the reference sheet so much, but I will. Let's start here. This is a pretty common question to ask. But I didn't explicitly put this on the common question sheet. But let's go ahead and do that. So if I wanted to find W prime of 5, the first thing we would do is we'd find W prime. So in that case, the 15 goes away because it's a constant. Next, when you take the derivative of this, the derivative will just cancel out the integral, and you're just going to be left with f of t minus g of t. Okay? And so W prime of 5 is equal to f of 5 minus g of 5. And we're just going to type that into our calculator to get our answer. Negative 2.402. Now we want to get our units. We want to find and interpret this, and interpretation should include context, it should include units, so we need to know what all this represents, right? Well, we already know that W represents the total amount, which means we're talking about gallons here. So what would W prime be? Well, remember, every time you do a prime, you get a per something. In this case, it's per minute. So W prime is gallons per minute. All right? So what does this represent, though? Well, this is a T value. T equals 5, and that's minutes. What is this? This is negative 2.402 gallons per minute. So what is my interpretation? Basically, this means that at T equals 5 minutes, the amount of water in the boat is decreasing at a rate of 2.402 gallons per minute. So I'll write that out. And there you guys have our little interpretation there. You need to pause the video and write that down. That's fine. All right, so I'm going to clear that out though and move on to our next one. Let's go and take a look at number 5. On what intervals is W increasing? So we will go back to our reference sheet for that. That's a pretty common type of question. When is the total amount increasing or decreasing? So it's increasing when the rate in is greater than the rate out. It's decreasing when the rate out is greater than the rate in. And the way that we solve this is we use our graphing calculator to graph it and find where they intersect. Now, if I is above O, like if this was my rate in function and my rate out function was here below it, on that interval then, where the rate in was greater than the rate out, here, that would be a place where the functions, the total amount is increasing because the rate in is greater than the rate out. Vice versa, if we were to flip it over, then it would be decreasing. So that's the idea there, is to graph the functions and find where they are decreasing. So let's go ahead and do that. I'm going to go to my handy dandy calculator here. And let's go ahead and graph those two functions. All right. I might have to adjust my window here a little bit. Doesn't look like a full view. So window, I know that my x values need to go from 0 to 5 at least. I'll go to 6 just in case. As for the y values, let's take it up to, I saw that the total amount of water in the boat was like at least 15 at some point in time. So let's go up to 20 for the maximum values there and see what that gives us. So there's one of my functions, and here's the other one. And as you guys can see, they do cross at a specific point here. So we need to find where they're crossing. So we do second calc 5 for intersect. We scroll to where they are crossing approximately, and we just push enter 3 times. And it looks like the crossing point is at x equals 3.942. Now, since this isn't going to be my final answer, I'm going to say 3.9418 just to be safe. We're going to take it out to the 4th number there. Now, what I want to do is I want to find out what is f of 3.9418, and I want to find out what is g of 3.94. Well, actually, at that point, they're going to be equal, so my bad. They cross at 3.9418. So we want to know which function is on top and which function is on bottom, where that's happening. So let me adjust my window a little more. I don't want to go quite that high. Let's go to like maybe 10 and see. So we know where they cross But now I need to figure out which one's on top. So to figure out which one's on top, we're going to do trace. And right now you guys can see where my cursor is tracing. It's tracing the one on top right now, and that is the sine function, which was my rate in. So it looks like all the way from t equals 0, which is way over here, all the way up to where they cross, the rate in is greater than the rate out, and therefore it would be increasing. The amount of water in the boat would be increasing on that interval. But after that, the rate in is below the rate out, and so then it's decreasing. So let's go back to our little worksheet here and see what they were asking for and how we're going to write our answer. On what interval is W increasing? So W increases. This is how you would write your explanation. When the rate in is greater than the rate out. This happens for 0 is less than or equal to t, which is less than or equal to 3.9, I forgot the number now, but I think it was like 94186, etc. So if we round it just here, that's fine. So we'll go ahead and round it to 2, because we are good at that point. So there it is, 3.942. So if you ever want to find where functions increase, the total amount is increasing on a rate in, rate out question, you just basically need to find where the rate in exceeds the rate out, and that would give you the point at which that occurs. Let's go ahead and move along here to part 6. What is the maximum amount of water on the boat? So for that, we're looking for the max or min. That's a candidate's test with T. Now, that means the total amount, so for us, that's W. So we're going to do a candidate's test. You're going to use the endpoints and the critical values. The critical values are the places where the two functions cross, which we've already found. So that we've already done a little bit of the work for this question already. So let's begin here. Let me make some writing space for myself. So, candidate's test. We're going to do the beginning time, the ending time, and that critical value time. And we're going to see which one gives the greatest value. Oops. Now, we already know what this first one is. The starting amount of water is 15 gallons. At 5 minutes, we already answered that question too, and we found that that was 18.012. And so now we need to figure out what that one is. And so we're just going to go back to that W of T function, the total amount of water function, and we're just going to be plugging in the 3.942 number. And for that, we'll use our graphing calculator once again. So I'll punch that in now, and we'll see what we get. 19.130. Okay? And so what is at what time do we have the maximum value? The time at which we have the maximum value is here. The actual maximum value is here. Okay? The time at which there is a minimum is here. The actual minimum value is here. Now this question was asking us to find the maximum. So the answer to this question would be 19.130 gallons is the maximum amount at any given time on the time interval 0 to 5. All right. Number 7 says, write but do not solve an integral equation that would find the time at which the amount of water in the boat is 10 gallons. So find the time when the amount is blank. Basically, you're going to find where your total amount question is equal to the amount that they're asking. Now, if you actually want to find the time, you'd have to graph both of those and find where they intersect. Now I'm not going to do that on this question because to graph the total amount function, that's an integral function, and the calculators take a while. So that's something that I would put off until the end if you ever had to do it on a test, because your calculator is going to get stuck and think for probably about 3 to 4 minutes before it can finally get it completely graphed. But if you do end up getting those, that's how you would do it. Now for my question though, I just said, let's write the equation but not actually solve it. So I want to know, when does the total equal 10? Well, the total amount is 15 plus the integral from 0 to t of f minus g. So I want to know, when does the total equal 10? And there's the answer. Now if you actually wanted, like I said, if you actually wanted to get this thing solved and find t, you would graph this integral function on your calculator. You would graph 10 and find where those two things cross. But your calculator has a very hard time graphing integral functions, so it'll take a long time. So that's why I just said write but do not evaluate. All right, but I have seen that question asked a few times. All right, X, number 8. Let's find and interpret f prime of 3. Okay, well, f was my rate in function. Well, as you guys know, for f, the units were gallons per minute. So what is f prime? Well, that would be gallons per minute, or in other words, per minute squared. So we have the units. What is the 3? Well, that's the t value. T equals 3 minutes. So what does it represent, though? Well, it represents the rate of change of f. And what does f represent? Well, f represents the rate at which the water is entering. So the interpretation would go like this. The rate at which water is being added that's just the contextual way of saying f. So the rate at which f is occurring is either increasing or decreasing. We're going to put a question mark there for now. The rate at which water is being added is increasing or decreasing at a rate of blank, because I haven't actually calculated it yet, so I don't know. So if it's negative, it's decreasing. If it's positive, it's increasing, and the actual number will go here. So the rate at which water is being added is increasing or decreasing at a rate of blank at t equals 3 minutes. So to fill in those blanks, I need to actually calculate some stuff now. So let's go to our calculator and find out. So we're going to do math 8 for derivative. We're going to find the derivative of our rate in function at x equals 3. And I get 0.035 for my outcome there. So the rate at which water is being added is increasing because it's a positive number at a rate of 0.035, and I should have put my units here, gallons per minute squared. So there's our interpretation. So since f represents gallons per minute, f prime represents gallons per minute squared. And what f is that's the rate at which water is being added. So f prime is the rate at which water is being added. Okay? And there you guys have it for that. So those are some of your more common types of questions for rate in and rate out questions. And then we'll put some of this stuff into practice when we see you guys in class next time. Till then, have a good one.